first video for Unit 6, Day 5. Today we're going to be working with trig identities. This is something you did a little bit of when you took Math 3, something that takes a lot of practice, so try and keep this video short and give you a lot of time in class for you to work through a lot and practice. The more you practice, the better you'll get working with these identities. Just to get started, we're going to give you some identities. These are ones you're going to have to memorize. You're going to have to know these off the top of your head without working them out, without having anything given to you. You're going to have to know these identities. So the first ones are called reciprocal identities, and these are three alternate trig functions that are reciprocals of our three basic trig functions. So first one, 1 over sine, is called cosecant. One over cosine, that's the reciprocal of cosine, is called secant. And then 1 over tangent is called cotangent. So those are our three reciprocal trig functions, or reciprocal identities. The next three are Pythagorean identities. They're all basically the same identity, we just rearrange it. So we take this for any angle, square the sine of the angle, square the cosine of the angle, add them together, it always equals 1. And this works for any angle, that's why it's an identity. So sine squared plus cosine squared equals 1. There's two ways we can rearrange this. We can say sine squared is 1 minus cosine squared, or we can say cosine squared is 1 minus sine squared. One important note about this, cosine squared is the actual value of the cosine ratio squared. Right, it's not the cosine of the square of the angle. It's important to make that difference. We put the notation with the squared in between cosine and the angle. We're squaring the whole value of the cosine, not the angle. And then the last identity is the alternate definition for tangent. In terms of sine and cosine, tangent is sine over cosine. So we can actually break all our trig functions down, the reciprocal trig functions and the basic trig functions, down into sines and cosines. Some things to remember while we're working through and verifying trig identities. This is different than solving an equation. That's the biggest thing to remember. We work with each side separately. We work with one side at a time. So this is not solving an equation where we can subtract 5 from both sides or add 5 to both sides, because we don't know if these things are equal. That's what we're trying to prove, is that they are equal. So if we subtract 5 from both sides, they're not equal, they're still going to be not equal. So we have to work with one side at a time while we go through these identities. So that page of identities on the last page, you want to look for those or try to create those, especially the Pythagorean identities will pop up a lot. Another thing, if you get stuck and you're not quite sure where to go, that alternate definition for tangent, you can always put everything in terms of sine and cosine. Sometimes that can help you get unstuck. If you get stuck there, change everything to sine and cosine, see if you can see some cancellation or something that will combine. And the fourth thing is there's a lot of different ways you can do. There's not one right way to go. Here the answer is not getting to the final answer, it's how you get to that final answer. So there's a lot of different ways to go, so important thing to do is think ahead, right? Look ahead in the problem and think what's going to be the shortest way to get from A to B. So we'll just go through a few examples, and then try and save you a lot of time to work on your own in class. This first one we have secant x times cotangent x equals cosecant x. Right, so here, again, working with one side at a time. So I'll start on this left side where I have two different terms. And I can use reciprocal identities to break these down. So secant is the same as 1 over cosine. Cotangent is the same as 1 over tangent. Right, I can now use a different definition for tangent, use definition in terms of sine and cosine, change that into 1 over cosine times 1 over, and tangent is sine over cosine. So now we have 1 over a fraction. What that does is it flips the fraction. So what I have now is 1 over cosine times cosine over sine. Right, and here we have cross cancellation. I have a cosine up here. We'll cancel with the cosine down here on the left. What I'm left with is 1 over sine. Our reciprocal of sine is the same thing as cosecant. Right, so we get to the same thing at the end. So we're done. We verified the identity. Worked with one side at a time, using only identities, not any algebraic steps, just changing things around using identities to get to what we had on the other side. So go to that same kind of thing for the second one. We have sine x times tangent x plus cosine x equals secant x. So again, we're going to work with one side at a time. Usually if you're not sure where to start with the more complicated side, because there'll be more things to simplify. So I'll go ahead here and try and put everything in terms of sine and cosine on the side. So I have sine x tangent, which is the same as sine over cosine plus cosine. Alright, so I can multiply sine x times tangent. I'll have sine squared x over cosine x plus cosine x. Right, if we want to combine these into one term, we're going to have to put them over a common denominator. Right, so denominator for this side would be cosine x. So I'd have to multiply this term by cosine x over cosine x to change the denominator. Right, and then this identity on the top, the Pythagorean identity, this is something that you're going to need to be able to recognize. When you see that, it should jump out. Sine squared plus cosine squared is 1. And then the reciprocal of cosine, 1 over cosine, that is the definition for secant. Right, so we verified that this identity is true. Everything on the left side is equal to secant. Again, we're only working with one side at a time. We're changing things using identities. We're not doing things to both sides. We're just working with one side at a time and rewriting things using identities, trying to make it match what we have on the other side of the equation. Right, and if we can do that, that means it's true. So just two more examples we'll go through, and then you can try some of these on your own. This next one we have cosine x minus cosine x sine squared is cosine to the third. So again, we're going to start on the side that looks the most complicated because we'll probably have the most stuff to simplify on that side. Right, so again, Pythagorean identities are something that should jump out. So here where I see I have a sine squared x, I know using a Pythagorean identity, anytime I have sine squared or cosine squared, I can rewrite it. So if cosine x minus cosine x, and we'll rewrite sine squared as 1 minus cosine squared. Right, now I can distribute this cosine through the parentheses. So cosine x minus cosine x plus cosine third x. Right in here I have a positive cosine x, negative cosine x. Those cancel out. I'm left with cosine to the third. Same thing I had on the other side of the equation. Right, so we worked the identities, we got back to the same thing, so we verified the identity, we proved that it's true. Again, anytime we see sine squared or cosine squared, that's something that should jump out to you and say we should probably be using a Pythagorean identity here. So last one, this one's a little bit trickier. We have some rational expressions involved, but it's the same basic idea. We're going to start on the side that looks the most complicated, obviously the left side, and we're going to try and work with some identities to make it equal what we have on the right side. So here again, just like on the last one, we have two rational expressions, two fractions. Want to combine them, we're going to need a common denominator. So to get a common denominator, I can always multiply the two denominators together. So I can multiply this fraction on the left by cosine. I can multiply this fraction on the right by 1 plus sine. So if I do that on the left side, I'll have cosine squared over cosine times 1 plus sine. Now on this side, we're going to have to FOIL, so we're multiplying a binomial. So we'll get 1 plus 2 sine x plus sine squared x over our common denominator, which is cosine x, 1 plus sine x. So now we're going to actually add them together, combine this all into one fraction. So I'll have cosine squared x plus 1 plus 2 sine x plus sine squared x all over cosine x 1 plus sine x. And now if you look in the top of this fraction, I've got a cosine squared plus a sine squared. Right, so together those are going to make 1. I already have a 1, so 1 plus 1 is going to be 2. Now looking at the top of this fraction, see I have a common factor of 2 I can take out of this term. So I can factor it. When I remove that factor of 2, I see I have a factor that cancels out the 1 plus sine x. I'm left with 2 over cosine x, right, which is the same as 2 times 1 over cosine x, or same as 2, the reciprocal of cosine, is secant x. So we get back to the same thing we have on the right-hand side using only identities, so we verified the identity. Again, this is something that takes a lot of practice, so it's important you work through a lot of problems on your own. There's not one right way to do it. Some ways take a little longer, some ways are a little shorter, but there's not one right way to do this. So there's a lot of practice problems for you to work on in class. If you want to see some other videos that might be a little more helpful than this one, you can search for Trig Identities.